Is going to cover a topic that I really enjoy, which is basically statistics. Uh, if we're at the beginning of statistics, the four most common things we work with are called mean, median, mode, and range. And as we work through them, they each represent a different part of the statistics. One of these is not better than the other. In fact, they're all very useful depending on the information that you're trying to figure out or answer. So let's start looking at each one of these individually first. Now, mode is not a very tough one to actually solve for. It is simply the most used number in a set of data. So whenever I'm working with numbers, one of the first things I like to do is writing the set of numbers in order, which I did up here in the top right just for the sake of time. And the mode is asking us the most used number in a set of data. So I simply look at the set and I see, is there a number that's used more often than others? And in this case, it's actually 5. And because 5 is used twice and no other number is used more than once, that means the mode of this set of numbers is simply the number 5. Now, if this set was used differently and this number changed here to, let's say, 5 3/10, all of a sudden no number in this set is used more than once. So you simply say that there is no mode in the set of data. So if every number is only used once, there is no mode. Otherwise, there is a specific mode. One other example of the problem could be if this set of data was 5 and 5, and then this turned into 6 and 6, you can actually have the mode be more than one number. So the mode here could be 5 and 6. That would actually not be a problem at all. So when we're looking at mode, it's the most used number in the set of data, and it can be more than one number. So let's try to undo everything I did here so we can get the set back to where it started. There we go. Okay, so in the next number is called range, or what I usually say total range of values. And that is simply the distance between the largest and smallest number in a set of data. When we're talking about total range, what we really want to know is what's the total distance. If you have a range that is a very high number, that means the distance from the smallest number to the largest number is a very, very large set. And if the range was small, that means the distance between them is actually very small. If I think of a sports example, high range, let's say you have two basketball players, and one of them has a very high range of scoring that they do in a season. Well, that means that they're probably pretty inconsistent, that they have some really, really good games and some really, really bad games. Whereas if a player has a small range, that would be a player who is very consistent and always scores kind of at the same amount. So for this set, we would simply look at our biggest number, which is 7, our smallest number, which is 3, and we simply subtract them. 7 minus 3 is 4, so the range for this set of data is 4. And if I remember correctly, the mode for this set was 5. So we have mode and we have range. Now let's move to the two things that we called the middle. Okay, we're going to look at mean first, and I like the word average, so I frequently will say average, but they mean the same thing. This is the middle of the data, but it's not actually the middle, okay? It's the set of data if every number was the same and the set's total stayed the same. So let's say we had 2 players who shot baskets, and one of those players made 4 baskets, and one of those players made 6. The mean, or the average, would be that each player made the same number of baskets, and the total stayed the same. Well, the total here is 10, and there are 2 players, so you would do 5 and 5. So the mean of this set would be 5. The other way to phrase it is it's the most typical or common number in the data set. Not used most often, but what the average person would do in that situation. The way to figure out average, which you've probably seen before, is total divided by pieces. So in this case here, there are 2 pieces, and the total is 10. So you do 10 divided by 2. And that's how you find it. But remember, It's if every number was the same, but the set's total stayed the same, which you can find by dividing. Now let's go down to median, which people actually refer to as the middle. This is the middle of a data set if all of the numbers were written in order. So for example, if we had a set of data that was 3, 8, and 11, the middle of this set would be, you look at the top number and the bottom number and you get rid of each, and that means that the number 8 is the middle of this set of data. Now there are some more special cases with median, but this is what people refer to as the middle. But remember, average is still technically the middle as well. So I don't actually like calling this the middle, but it's the middle of the data set if the numbers are written in order. Mean is the middle of the data set in the way that if the set's total was the same, but everyone scored the same amount. Okay? So let's look at mean and median for a larger set of data and what they show about that set of data. So 5 students sold magazines for their class trip fundraiser. Here are the totals of their sales. So 1 student sold 8 magazines, 1 student sold 7, 1 sold 2, 1 sold 3, and 1 sold 5. Whenever we're doing anything with statistics, I want to write this set of data in order. So I'm going to change this to 2, 3, 5, 7, and 8. Always easier to work with a set of data if it is written in order. Now, median is almost always the easiest thing to find first, at least compared to mean. So what I do is I simply look at the bottom number and the top number, and they are going to be opposites of each other because we're looking for the middle. So we can get rid of the top and bottom. And then we do that again. We look at the next top and the next bottom, which means that the middle number, when the set is written in order, is 5. So the median here is the number 5. Now the mean, remember we're going to be doing the total divided by the parts. So we need to add all of these up. 8 plus 7, well, that's 15. 2 plus 3, well, that's 5. And we have 1 extra 5, so this is 20. Plus 5 is 25. So our total is 25. And there are 5 parts. Therefore, the mean for this set of data is actually also the number 5. Will the mean and the median be the same? Honestly, very rarely. It really depends on the set of data that you're looking at and really what that data is. One big number has a much higher impact on the mean than it does the median, and I'll show you what that looks like. So let's go back to our set and let's pretend one person was just an awesome overachiever and they sold 80 magazines. And let's look at the impact that that has on the mean. If we remember, they're both 5 without that 80 in there. Okay, so let's find the median again. So biggest and smallest, next biggest, next smallest. And then we are stuck with 2 numbers. If you ever have 2 numbers in between the median, we can't cross them both out because then it get rid of everything. So what we do is we imagine that there is a number halfway between these 2 numbers. Well, the number halfway between 5 and 7 is 6. Therefore, the median is the number 6. But when we're actually working with this set again, we do not include that number for the mean at all. Okay? So let's now do what we did before and find the mean. We know that these were all 25. So then we're going to add 25 plus 80, which is 105. And now we have to divide by 6. Okay? So this, 1/6 can fit into 10 without going over. So this turns into 45. And if we're trying to do 45 divided by 6, the closest multiple would be 7. So this ends up being 42. Well, now we have a remainder, so let's add a decimal here. And we're going to divide by 30 divided by 6 is 5. So that means the mean changed to 17.5. Okay, so without the number 80, the mean and the median were both 5. When we added one giant number in, The median didn't change very much at all, but the mean jumped a ton. And what I'm hoping that shows you is that for small sets of data, the mean can be impacted by one really large or really small outlier a lot more than the median will. And that frequently will happen. So depending on what argument you're trying to make, sometimes the mean will be better, sometimes the median will be better. Let's do a problem where we put this all together and we find mean, median, mode, and range all in one problem. So let's look at the story problem here. It says Mr. Schmidt gave 10 students 10 pieces of candy, which he's a really nice guy, but the candy's caramel corn, which is like the worst candy ever, so not really that nice. Then the students raced to see who could eat the candy the fastest. And here are their total times in seconds, and it's asking us to find the mean, median, mode, and range of this set of data. Well, since we have a set of data, the first thing that I like to do is write the data in order from smallest to largest. So I'm going to do that. First number, smallest number, is 15. Then we have 32 and 34. From there we have 43 and 45. Then 71, 72, and 73. Then 88 and 102. Okay, so since we have the set of data written in order, the first thing we want to do is probably find the range. Okay, the range is simply the gap between the largest and smallest numbers. So we have largest is 102, smallest is 15. So let's subtract them and see what the largest and smallest number is. So I need to borrow in the ones place, but I can't borrow from there. So we'll turn that to a 10 and then borrow 1 to turn into 9 tenths. And then we'll make this a 12. So this ends up being 7 and 8. So our range is 87. And that means the gap between largest and smallest is 87 seconds. Next easiest to find is mode, which asks us, is any number used more than once? And I look at my set. Every number is used exactly one time. Therefore, there is no mode. Okay, not too bad there. And now we have median. So we are going to try to find the middle number when the number set is written in order. So I'm going to go largest and smallest. They cancel each other out. Next largest, next smallest, again, and we are stuck with two numbers because we have an even number in our data set. So we're going to have to average or find the number that's halfway between 71 and 45. Now, we could add these numbers together and divide by 2. That's a pretty easy way to find average. But the other thing you can do is you can think about finding a number that is equal distances away from 45 and 71. So if I picked a number that was 10 bigger than 45, that would be 55. And if I picked a number that was 10 smaller than 71, that would be 61. And if I can find a number that is the same distance away from each, then we will have the average. So we know that 10 away from each doesn't work. So let's try 12. 12 bigger than 45, well, that is 57. 12 smaller than 71, that's 59. Ooh, we're really close. So let's try 13. Let's try 13 bigger and 13 smaller. So 13 bigger than 45, that's 58. And 13 smaller than 71, also 58. So then the median here is the number 58. Remember that this is not actually part of the data set. It is just halfway between the two middle numbers. So let's erase everything here, and we are going to now do the mean or the average, which is usually the toughest thing to find from a data set. So in order to find the mean, it's asking us if the total was the same but every number was equal. What would that number be? Well, the easiest way to find that is to add all of the numbers together and then divide by the number of pieces in the data set. When we add all of these together, we get the number 575. And I'm going to give you that number because it takes a long time to add it, and I want to keep the video short. There are a total of 10 students, so I'm going to divide this number by 10. And now I just simply do long division. So the closest multiple to 57 of 10 is 50, so 5. And now I subtract, and I have 75 left over. So the largest multiple of 10 we can use next is 7 tens. And that gives us 70. And now we have a remainder of 5. But since we know decimals, we're going to add a 0 after the decimal place and bring that 0 down. And 50 divided by 10 is exactly 5. So that means our average, or the mean, for this set of data is 57.5. And that right there is finding the mean, median, mode, and range for a set of data. If you want to see more examples of how we can use mean, median, mode, and range, there is another video entitled Are Girls Better Than Boys at Sports?, which is a pretty fun video to make, and I hope you enjoy watching it as well.